What is a decentralized application? A decentralized application is an application that can operate autonomously, typically through the use of smart contracts, that run on a decentralized computing, blockchain or other distributed ledger system. Like traditional applications, dApps provide some function or utility to its users. However, unlike traditional applications, dApps operate without human intervention and are not owned by any one entity. Rather, dApps distribute tokens that represent ownership. These tokens are distributed according to a programmed algorithm to the users of the system, diluting ownership and control of the Dapp. Without any one entity controlling the system, the application is therefore decentralized. Decentralized applications have been popularized by distributed ledger technologies, DLT, such as the Ethereum blockchain, on which dApps are built, amongst other public blockchains. The trustless and transparent nature of dApps have led to greater developments in the utilization of these features within the decentralized finance (DeFi) space. dApps are divided into numerous categories: exchanges, games, finance, gambling, development, storage, high risk, wallet, governance, property, identity, media, social, security, energy, insurance, health, etc. Definition. There are a series of criteria that must be met in order for an application to be considered a Dapp. Traditional definitions of a decentralized application require a Dapp to be open source. That is, the application operates autonomously without a centralized entity in control of the majority of the application's associated tokens. dApps also have a public, decentralized blockchain that is used by the application to keep a cryptographic record of data, including historical transactions. Although traditional dApps are typically open source, dApps that are fully closed source and partially closed source have emerged as the cryptocurrency industry evolves. As of 2019, only 15.7% of dApps are fully open source while 25% of dApps are closed source. In other words, the proportion of dApps with publicly available code is less than the proportion of dApps without publicly available code. dApps that are open source generally have higher transaction volumes than closed-source dApps. Secondly, tokens, required for application use and user rewards must be generated by the application as per a programmed algorithm or criteria. A portion of the application's tokens is typically distributed at the beginning of the application's operation. Lastly, the protocols of the application must be able to adapt in favor of majority consensus by the application's users, such to make improvements to the application based on market feedback.
Bitcoin as a Dapp. Bitcoin, the first cryptocurrency, is an example of a Dapp. Bitcoin is open source. All transactions on the Bitcoin blockchain are open, public, immutable, and operates without the control of any centralized entity. This means every Bitcoin transaction since the beginning can be seen by everyone. Bitcoin generates its own Bitcoin tokens, through block rewards to miners for securing the network. Block rewards are halved every 210,000 blocks mined, or roughly every 4 years, to limit the inflationary effects on Bitcoin, thus, capping the number of total Bitcoins at 21 million. Changes to Bitcoin must be made through Bitcoin's proof-of-work mechanism, which can only be done by majority consensus of Bitcoin's users. Classification. dApps can be classified based on whether they operate on their own blockchain, or whether they operate on the blockchain of another Dapp. By this classification, dApps are divided into 3 types. Citation needed. Type 1 dApps operate on their own blockchain. Blockchains such as Bitcoin and Ethereum can be classified as Type 1 dApps. Type 2 dApps are protocols that operate on the blockchain of a Type 1 Dapp. These protocols themselves have tokens that are required for their function. Type 3 dApps are protocols that operate using the protocols of a Type 2 Dapp. Similar to Type 2 dApps, Type 3 dApps also have tokens that are required for their function. Smart contracts. Smart contracts are used by developers to maintain data on the blockchain and to execute operations. Multiple smart contracts can be developed for a single Dapp to handle more complex operations. over 75% of DApps are supported by a single smart contract, with the remainder using multiple smart contracts. DApps incur gas, that is fees paid to the validators of the blockchain, due to the cost of deploying and executing the Dapp smart contracts. The amount of gas required of a Dapp's functions is dependent on the complexity of its smart contracts. A complex smart contract of a Dapp that operates on the Ethereum blockchain may fail to be deployed if it costs too much gas, leading to lower throughput and longer wait times for execution. Operation. Consensus mechanisms are used by DApps to establish consensus on the network. The two most common mechanisms to establish consensus are proof of work, POW, and proof of stake, POS. Proof of work utilizes computational power to establish consensus through the process of mining. Bitcoin uses the proof of work mechanism. Proof of stake is a consensus mechanism that supports DApps through validators that secure the network by having a stake and % ownership over the application. A Bitcoin mining rig composed of dozens of graphics processing units. DApps distribute their tokens through three main mechanisms: mining, fundraising and development. In mining, tokens are distributed as per a predetermined algorithm as rewards to miners that secure the network through transaction verification. Tokens can also be distributed through fundraising, whereby tokens are distributed in exchange for funding in the initial development phase of the Dapp, as in an initial coin offering. Lastly, the development mechanism distributes tokens that are set aside for the purpose of developing the Dapp through a predetermined schedule. There are three main steps that always occur in the formation and development of any Dapp: the publishing of the Dapp's whitepaper, the distribution of initial tokens, and the distribution of ownership. Firstly, the whitepaper is published, describing the Dapp's protocols, features and implementation. Then, required software and scripts are made available to the miners and stakeholders that support the validation and fundraising of the network. In exchange, they are rewarded with the initial tokens distributed by the system. Lastly, as greater numbers of participants join the network, either through utilization of the Dapp or through contributions to the Dapp's development, token ownership dilutes, and the system becomes less centralized. Characteristics. DApps have their backend code running on a decentralized peer-to-peer network, as opposed to typical applications where the backend code is running on centralized servers. A Dapp can have front-end code and user interfaces written in any language that can make calls to its backend.
DApps have not achieved wide adoption. Potential users may not have the skill or knowledge to be able to effectively analyze the differences between DApps and traditional applications, and also may not value those differences. This skill and information can be difficult to access for mainstream users. Additionally, the user experience for DApps is often poor, as they are often developed to prioritize functionality, maintenance and stability. Many DApps struggle to attract users, particularly in their founding stages, and even those that attract widespread initial popularity struggle to retain it. Full citation needed. A notable example was the Dapp CryptoKitties, which heavily slowed down the Ethereum network at the height of its popularity. CryptoKitties and another similar gaming-based Dapp dice games have failed to attract similar traction since. Examples: Augur, prediction market platform. CryptoKitties, game built on Ethereum. It slowed Ethereum down due to insufficient transaction processing and exposed the scaling limitations of public blockchains. Stacks Project, a platform for developing decentralized applications. Freelance, platform on smart contract. Steemit, blogging and social media. Uniswap, a decentralized cryptocurrency exchange.
What is decentralized computing? Decentralized computing is the allocation of resources, both hardware and software, to each individual workstation, or office location. In contrast, centralized computing exists when the majority of functions are carried out, or obtained from a remote centralized location. Decentralized computing is a trend in modern-day business environments. This is the opposite of centralized computing, which was prevalent during the early days of computers. A decentralized computer system has many benefits over a conventional centralized network. Desktop computers have advanced so rapidly that their potential performance far exceeds the requirements of most business applications. This results in most desktop computers remaining idle in relation to their full potential. A decentralized system can use the potential of these systems to maximize efficiency. However, it is debatable whether these networks increase overall effectiveness. All computers have to be updated individually with new software, unlike a centralized computer system. Decentralized systems still enable file sharing, and all computers can share peripherals such as printers and scanners as well as modems, allowing all the computers in the network to connect to the Internet. A collection of decentralized computer systems are components of a larger computer network, held together by local stations of equal importance and capability. These systems are capable of running independently of each other.
Origins of decentralized computing. The origins of decentralized computing originate from the work of David Chaum. Citation needed. During 1979 he conceived the first concept of a decentralized computer system known as mixed network. It provided an anonymous email communications network, which decentralized the authentication of the messages in a protocol that would become the precursor to onion routing, the protocol of the Tor browser. Through this initial development of an anonymous communications network, David Chaum applied his mixed network philosophy to design the world's first decentralized payment system and patented it in 1980, patent US 4,529,870. Later in 1982, for his PhD dissertation, he wrote about the need for decentralized computing services in the paper computer systems established, maintained and trusted by mutually suspicious groups. He would go on to launch the world's first digital payment system in 1990 called eCash. DigiCash. Peer-to-peer. Based on a grid model, a peer-to-peer system, or P2P system, is a collection of applications run on several computers, which connect remotely to each other to complete a function or a task. There is no main operating system to which satellite systems are subordinate. This approach to software development and distribution affords developers great savings, as they don't have to create a central control point. An example application is LAN messaging, which allows users to communicate without a central server. Peer-to-peer networks, where no entity controls an effective or controlling number of the network nodes, running open-source software also not controlled by any entity, are said to affect a decentralized network protocol. These networks are not easily shut down by traditional court jurisdiction means, because the protocols have no central or headquarters jurisdiction in which they operate. The network operates on the principles, and according to the code, that is running on the network. In the 2010s, a number of such decentralized network protocols emerged. By early 2021, the most used decentralized protocols included the Bitcoin, Ethereum, and Binance Chain blockchains, and the Uniswap, SushiSwap, and Compound Decentralized Finance (DeFi) protocols.
File sharing applications. One of the most notable debates over decentralized computing involved Napster, a music file sharing application, which granted users access to an enormous database of files. Record companies brought legal action against Napster, blaming the system for lost record sales. Napster was found in violation of copyright laws by distributing unlicensed software, and was shut down. After the fall of Napster, there was demand for a file-sharing system that would be less vulnerable to litigation. Gnutella, a decentralized system, was developed. This system allowed files to be queried and shared between users without relying upon a central directory, and this decentralization shielded the network from litigation related to the actions of individual users.
What is Decentralized Network 42? Connected to Darknet Anonymity Virtual Private Network. From Wikipedia, the free encyclopedia. Decentralized Network 42, also known as DN42, is a decentralized peer-to-peer network built using VPNs and software, hardware BGP routers. While other darknets try to establish anonymity for their participants, that is not what DN42 aims for. It is a network to explore routing technologies used in the Internet and tries to establish direct non-NAT-ed connections between the members. The network is not fully meshed. DN42 uses mostly tunnels instead of physical links between the individual networks. Each participant is connected to one or more other participants. Over the VPN or the physical links, BGP is used for inter-as routing. While OSPF is the most commonly used protocol for intra-as routing, each participant is free to choose any other IGP, like Babel, inside their AS. History. The DN42 project grew out of the popular Peer-IX project started by Hard Forum members in mid-2009. The Peer-IX project, while small in initial numbers, grew to over 50 active members with a backlog of 100 requests to join the network. Ultimately, the project was unable to meet the demand of user scale and eventually deprecated, though many of the core member teams still have their networks online. The founding members of the DN42 project tried to unsuccessfully rekindle the Peer-IX project through the private Google group, and instead formed their own IPv6-only network, successfully scaling it to the size it is today. Technical setup. Address space. Network address space for IPv4 consists of private subnets. 172.20.0.0/14 is the main subnet. Note that other private address ranges may also be announced in DN42, as the network is interconnected with other similar projects. Most notably, Chaos VPN uses 172.31.0.0/16 and parts of 10.0.0.0/8. 5. Freifunc-IC VPN uses 10.0.0.0/8, 6, and Neo Network uses 10.127.0.0/16, 7. For IPv6, Unique Local Address (ULA), the IPv6 equivalent of Private Address Range (FDOO), skeptical smiley face 84 are used. Please note that other networks use IPv6 addresses in this range as well, including NeoNetwork's use of FD10 to 127, skeptical smiley face 32.
As numbers. In order to use BGP, even in a private environment, autonomous system numbers are needed. DN42 uses several private or reserved as numbers ranges, including 64,512 to 64,855 and 76,100 to 76,199. 8. Since June 2014, DN42 is now using a new private range, 4,242,420,000 to 4,242,429,999. 9. Part of larger private range defined by RFC 6996. BGP routers. While some participants use hardware routers, most participants use general-purpose servers or virtual machines to lower their cost. The most commonly used BGP implementation used in DN42 are BIRD and FRR, but some participants use OpenBGPD, XORP, GoBGP, or the implementation of Junos or Cisco IOS. DN42 DLD. Websites and services hosted on the DN42 network often use the DN42 top-level domain. The DN42 DLD is not an official IANA top-level domain, but it is handled through the DN42 registry. Internal Anycast servers for DN42 are found at 172.20.0.53, 172.23.0.53, and FD42, D42, D42-54, 1, FD42, D42, D42, 53, 1. Tell other friends.